All right, hey students. So today we're going to do this review to remind ourselves what systems of equations and inequalities is. So the first question is asking you to graph an inequality. Y is less than negative x plus 2. And this is very similar to the equation y equals negative x plus 2. Whenever you graph this in the calculator, you can only, at the moment in Algebra 1, graph like if it's an equation. So you will just go to graph and type negative x plus 2. And you're just going to get a line. The line that you get here on the screen is what you are able to plot here. To plot correctly, you will have to press Control T. So the button Control and then the letter T. And that will give you the table. So this table is the points that you're going to plot. So right away you can see it's 1, 1. We plot that point. 2, 0. X is 2, y is 0. 3, negative 1. X is 3, y is negative 1. And just with those 3 points, you can see that the rise over run ratio is drop 1, run 1. Drop 1, run 1. So you're going to keep going with this pattern to get more points on your line. If you run out of space, you go opposite, up 1, left 1. And then you just keep going. So there, we went ahead and traced the line that you see on the screen. We're now going to decide what we're going to draw as far as the line goes. So the inequality, the symbol less than, will tell you that. And if you, in case you're still confused whether this is less or greater, remember you could do the L with your hand. That is for the less than symbol. So this is less than, and we're talking about y values that are less than something. So we're looking at the y values, meaning the y-axis. If this is 0, the y values that are less than 0 are below. So this is the line that you're going to be shading below. And also this symbol, we said that it was going to be a dashed line. So we're going to go ahead and draw dashed line through those points. And we're going to shade below. Okay? That's your first example. You're more than welcome to pause this video as needed to do your work and then check if you did it correct, if you're watching it individually or just reviewing. If you're watching it as a class, just let the teacher know. Number 2 says, which of the following is a solution to the inequality y is less than negative 2x plus 5. So because there's no graph here, I do kind of want to help you with strategy. So please try to make a sketch. You're more than welcome to graph it in the calculator as well. So Control T removes the table, and then now you can do Doc B to clear. So we type negative 2x plus 5. And again, this gives you an idea of what the graph looks like. But again, this is a sketch. So to be exact, you can graph this by hand. Remember that it's mx plus b. B is your y-intercept. That means that this line is going to touch at 5. 1, 2, 3, 4, 5. The line is going to touch at 5. And then the slope is negative 2. When the slope is a whole number, you want to put it as a fraction so you can know what your rise over run ratio is. So this means we're going to be rising down 2 units and running 1 across. So 1, 2, and then 1 across. 1, 2, 1 across. So again, it's a sketch, it's not going to be perfect. And then we go 1, 2, and 1 across. Again, I already drew the line, but that's just the tendency we have. We plot points and we draw a line. However, go back to the symbol and double check if it is a solid line or a dashed line. So because the symbol is once again a less than symbol, this is just like the one above, a dashed line, and it's shaded below. So I'm going to, it's an erasable pen, so I'm going to just erase parts of the line so it could look dashed. If you are writing in pen, I will strongly recommend you to kind of just run over it with a bolded dash line to remind you that it's dashed. And we shade below. So this sketch can help you confirm if these points are solutions or not. And just to remind you of the solutions, that is where the shaded area is. So right away, 0, 0 is the origin. That is definitely in the shaded area. So that is a solution. 0, 5. 0, 5 is the y-intercept. But again, because it's a dashed line, dashed lines do not contain solutions. So I will say no to that one. Make a note somewhere on yourself that dashed lines don't have solutions. And then 0, 4, 1, 2, 3, 4, that is below the y-intercept. So that is definitely also a solution. Okay? All right. Number 3. Write an inequality in standard form to represent the graph to the right. So this is a super challenge for most of you. Pretty much you need to write the equation in form of y equals mx plus b. And then from there you convert that into standard form. But keep it in mind that we have inequality symbols instead of the equal sign. All right, so let's go ahead and look at the facts. This is shaded to the right side, but we cannot say left or right. We gotta say above or below. So if this is the line, above will be this way and below will be this way. So right now we can say that it's shaded below. And then it's a dash line. So that means we're gonna have a symbol that is not gonna have the equal to, and it's gonna show below. So lucky you, these previous two examples show below. So that means the symbol we're gonna use is less than. Now, how do we write mx plus b? Well, once again, what's your y-intercept? And then look for another perfect point so we can find a rise over run ratio. So it looks like right here is a point, maybe also here. That is an exact corner between the grid. And it seems to be the pattern. So the pattern seems to be up 3, run 1. Up 3, run 1. Up 3, run 1. So that means our slope is 3. Our p-value is -5. So with this information right here, we can write our inequality. Y is less than 3x minus 5. Okay. To turn this into standard, we need to remember that standard form has the x and the y together on the left side. The inequality symbol depends because it could flip. And then the c value, meaning the constant, stays by itself on the right side. So I'm just going to draw this imaginary line to kind of guide us on how to move the terms around. Okay, so the 3x right here, that needs to disappear because it needs to go to the left side. So we move it by subtracting 3x from both sides. Cancels. We're left with -3x positive y less than -5. And the thing about standard is that it has to follow certain rules. A cannot be negative, like right now it's negative. We need to make that a positive. And A, B, and C cannot be fractions or decimals. So far they're all whole numbers, so we just need to get rid of that negative. And one quick way to get rid of the negative is to multiply everything times -1. So -1 times -3 will be 3x. -1 times positive y is -y. We are multiplying times a negative, so we need to flip the symbol. And then -1 times -5 is +5. So this will be the standard form equation of this inequality. All right, here's number 4. So number 4 is given to you in standard. And you need to turn that into y equals mx plus b mode in order to be able to graph it. So pretty much what we did here, but backwards. So we have -3i plus 6x less than or equal to 12. We want y by itself, so the 6 needs to go. -6x minus 6x cancels. And we're left with -3y less than or equal to -6x plus 12. Final answer will be to divide by -3 well, final step, I'm sorry. Okay, so that cancels out negative 3y. We are dividing by negative, so the symbol needs to flip. Negative divided by negative is positive, so that's 2x. Positive 12 divided by negative 3, that's negative 4. So the inequality that we're going to graph is going to be y is greater than or equal to 2x minus 4. And following the previous examples, we can graph this by hand once it's in slope-intercept form. So m is your slope of 2, b is negative 4. Your slope needs to be in a rise over run ratio. So we're going to be rising 2 and running 1. And we're going to be starting at negative 4. So plot that point at negative 4. You're going to rise 2 and run 1. And just plot more points there. Rise 2 and run 1. Okay, and then we stop as far as graphing goes. Now we're going to decide whether we're going to have a shaded area that's above or below, and if we're going to have a dashed or solid. So it goes back to focusing on the symbol. If your symbol is greater than or equal to, this is definitely different than all these previous examples because it has the equal to. So this is the one that is a solid line. And then also, if you do the L with your hand, this does not match that symbol. That means that this is greater than. Greater than would be, if we look at this little quick line, greater than would be above. So we're going to shade above. So let's draw a solid line and shade above. Done. Okay, so here number 5, like I said, pause the video if you want to try it on your own, following the previous steps. But let me go ahead and continue for those of you who are ready. We write down the standard form, and we can only graph it. Oh, sorry, it's just greater than. We can only graph it if it's in mx plus b mode. So we need to get the x on the other side. Negative 2x on both sides cancels. You're left with negative 3y greater than negative 2x plus 6. Last step is to divide by negative 3. And again, we're dividing by negative, so we have to flip that sign. Negative divided by negative is positive, so 2/3, positive 2/3 x, and positive divided by negative is negative. 6 divided by 3, 2. So this is the inequality that we're going to be graphing here. And identifying the m and b can help us graph it by hand. So m, that's 2/3. You're going to be rising 2 and running 3. B is negative 2, so that's where we're starting. So negative 2, rise 2, run 3, 1, 2, 1, 2, 3, plot a point, 1, 2, 1, 2, 3, run out of space, go backwards, 1, 2, 1, 2, 3. Okay, so those are the points that would give us that line. Now are we going to have a dashed or solid? Well, let's focus back on that symbol. The symbol is less than. So less than is the symbol that we have been using on 1, 2, and 3. So that means we are going to have a dashed line and shade below. And once again, L with your hand shows that this is a less than. And dash that line. All right, so that was a quick review on graphing inequalities. Back of this paper, now we have just systems of equations. Okay, so number 5, 6, and 7 is writing the equations and maybe solving. And definitely number 8, 9, and 10 is just abstract, no real world, but still solving systems of equations. So number 5 says a large pizza at Palancio's Pizzeria costs $6.80 plus 90 cents for each topping. The cost of a large cheese pizza at Guido's Pizza is $7.30 plus 65 cents per topping. So this goes back to remembering how to write equations, but now you're writing 2 in one example. So the first one will say per or for each. Remember, this will be your m, because this is the one that is per something for x. Meaning that if we write that equation, we're going to have y equals 90 cents per topping plus $6.80. Okay, so that will be for Palancios. And then the other one will be 65 cents for each topping. So 65 cents for each topping plus $7.30. And this will be for Guitos. Okay, it just asks you to write a system. We wrote a system, so that's it. Good job. If you want to pause the video and try the other two, you can, or just keep watching and learn with me. A movie theater sells adult tickets and children's tickets. Adult tickets cost $12 and children's tickets cost $8. At one show yesterday, the movie theater sold 450 tickets, totaling 4,800. So right away, they're talking about two things that you don't know. You don't know the adults tickets, and you don't know the children's tickets. Okay. So then now, based on the information given, they're telling you that they sold 450 tickets. And from the practice we've been doing, we know that we can write an equation of the amount of tickets, because whatever amount of adult tickets were sold and whatever amount of children tickets were sold together, they're 450. So this is that equation that looks just simply as x plus y equals 450. The other equation will be money. So we're talking about how much money was collected. So therefore, we're now going to talk about the money for each. Adults, those were $12 each. So we're going to say that it's $12 per adult plus $8 per child. And whatever amount of tickets were sold, each one brought so much money. And together, that money cost or was 4,800. So this will be your two equations for this scenario. The question is just asking you to write the system. So that was it for that. On number 7, you have a $1.55 in dimes and nickels in a jar. There are 23 coins in total. How many dimes and nickels do you have? So this one's actually asking you to write and solve. The ones above were just to write. Okay. So this one, besides writing two equations, we now have to use our calculator to also find the answer. So you have $1.55 in dimes and nickels. So those are your two unknowns. Dimes and nickels. And there's 23 coins in total. So similar to the one above, we're going to say that one equation says that there's 23 in total, meaning whatever amount of dimes you have, whatever amount of nickels you have, together they add up to 23 coins. The next one is the money, just like the previous one. So if together they're $1.55, we need to put how much money each one is worth. So the dimes, those are 10 cents. So 10 cents per dime plus 5 cents per nickel. So be very careful on this one. 5 cents is 0.05. I've seen many of you write 0.5. 0.5 is wrong. Make sure you put 0.05. So now we have our system of equations. We're technically halfway there. Okay. So now we gotta solve. Well, how do we solve? Two methods that I taught you at least. One will be graphing. But if you're gonna graph, you need to have both of them in y equals mode. You need to rewrite both of these in y equals. Or you can be lucky enough to use the program and use linsolve, which that one seems to be the one you guys like the best. So just to refresh your memory on what that is, go to your calculator, clear it. Here in the section of calculating, we're going to just type menu. So that button right here, menu. We're going to press algebra. And then we're going to select numeric solve. Ooh, apparently it's locked. So maybe you won't be able to use it. So let's go ahead and do the other way. Okay, let's rewrite these in y equals. So if we write that one as y equals, we just need to rewrite it, move the x to the other side, so minus x, y equals, and you could write it as 23 minus x. That your calculator will take. Next one will be 0.10x plus 0.05 y equals 1.55. And you can rewrite that as moving that 0.10x, subtracting it from both sides. And then you're left with 0.05y equals 1.55 minus 0.10x. And then the last part will be to get rid of that 0.05. So we divide. And this is why it's important to remember how to convert standard to slope-intercept. All right, so your final notation that you can type in your calculator is 1.55 minus 0.10x over 0.05. And again, this is a notation that the calculator does accept, but for those of you who want to graph it by hand, you can always simplify. So if you divide $1.55 by 5 cents, you get 31. So this part will be y equals 31 minus, so 0.10, well, it's actually negative 0.10 divided by 0.05, and that's -2. So this is the equation simplified. But for those of you who want to have it as mx plus b, we will have negative 2x plus 31. I know, there's a lot of options, but stick with these two for now if you want. So let's go to graph, and let's graph those two equations, sorry. So 23 minus x, and you could just press down, and you can type the other one. It's a fraction, so control, and then divide takes you that division section, so 1.55 minus 0.10x over 0.05. And there's nothing when I press enter, which means that I did graph them, so I need to zoom out. Maybe they're somewhere out there. So by zooming out, there they are. And now that you see where they intersect, let's find where that is. So you're going to go to Menu, Analyze, and Intersection. And then you create like a wall. Remember, this is where they intersect. So you got to just move it to the left somewhere, scroll over, and there it is in black, 8, 15. So if the two lines cross at 8, 15, now we need to interpret what does that mean. So x, y, go back to your label right here, x, y, so 8 is the x, and the y is the 15. And to answer the question, how many dimes and nickels do you have? You have 8 dimes, and you have 15 nickels. So that takes care of that. All right, so it seems that the process that we just did right here is what we're going to have to do if we encounter systems of equations that are in standard form. So pause the video so you can practice that conversion process on your own, but you can also just keep watching if you want to just watch how to do it again. Again, the reason why we did it by graphing was because if we do the other method of algebra, solve systems is not active. Like I can't do anything other than and solve. So we cannot do then solve anymore. Make sure you guys practice graphing by hand, okay? I mean graphing in the calculator, but rewriting this first. So 2x plus 5y equals -4. Move the 2x to the other side. Now you have 5y equals -4 minus 2x. Divide by 5. So you can just type in the calculator -4 minus 2x over 5. And that will be an equation that you can graph. The other one is also standard. So let's do that one over here. So minus 3x on both sides. And you're left with -y equals 11 minus 3x. divide by -1, y equals negative, well, I guess we can leave it like that if you don't want to simplify, and then just type that. Those of you who do want to simplify, remember you can, and if you want to take it as far as mx plus b, you can. I just want to make sure I write at least an example for the simple. It's a simple way to convert to quickly graph. So clear it, and then go back to graphing, and then just type control divide -4 minus 2x over 5. Press down, and then now type the other one, control divide 11 minus 3x over -1. Okay, when you find those two lines intersecting, menu, analyze, intersection, click and then drag, and there it is, 3, -2. So graph, given the system, what is the solution? You just write 3, -2. Okay. Next one, is the point 1, 5 a solution to the system? Well, it's pretty much do what we just did, but now just say yes or no at the end. So this first one is already ready to be graphed. The second one needs to be converted. So the x doesn't belong here. Subtract x from both sides. -y equals -5 minus x. Divide by -1. So we can graph y equals -5 x. -5 minus x over -1. So let's go ahead and graph these two. I'm going to clear the calculator and try graphing again. So 2x plus 4. And then control divide, -5 minus x over -1. The intersection, it's way up here, but you can still see it, so it's still going to calculate it for you. So menu, analyze, intersection. If for some reason you don't see the intersection, you need to zoom out until you see it. Okay, so by doing this, I know it's way in there, but if you can see it, it is 1 and 6. You can also confirm this in the table. So if you press Control T, you get the table right here, and if you notice at the top, these are the answers of the y values of the blue. If you press on the right, these are the y values of the red. So notice that when x is 1, both of the tables have a 6. That's the only number that both tables have the same number. So definitely the answer is 1, 6. Is the solution 1, 5 the correct solution? You're going to put no. Okay, so no, and then 1, 6 is the correct solution. All right, last question and we'll be done. Both of these are in standard, so once again, you need to rewrite both of them. So this is why we practice, practice, practice until it becomes easy. I'm gonna set these up, ready to be rewritten. So 3x doesn't belong there. Move it to the other side, minus 3x. Now you have 2y, 8 minus 3x. Divide by 2. Y equals 8 minus 3x over 2. So at this time, like I said, you don't need to simplify or change anything because that is something the calculator takes. X doesn't belong, so we subtract, put it on the other side. So 2y equals 4 minus x. Divide by 2. Divide by 2, so y equals 4 minus x over 2. Alright, so they give you the option here to graph it by hand if you want. If we do graph it by hand, we do need to have these in mx plus b mode. So we do divide both by 2 to simplify, if you want to go that route. You can always graph it in the calculator like we've been doing, and then just find where they intersect. Just for those that do want to do it by hand though, I'll go ahead and proceed the video by hand. So I'm going to go ahead and convert these into mx plus b. mx plus b, the one with the x is the mx. So negative 3 divided by 2, that's going to stay as negative 3 divided by 2. And then 8 divided by 2, that's 4. So that's plus 4. So this is your equation right here in mx plus b. Y equals negative 3 over 2x plus 4. This one, if we divide by 2, it's going to become, once again, if we do mx plus b, the one with the x is your m. So negative 1 over 2, you can put it as negative 1/2 x. 4 divided by 2, that's 2, so we put 2. So y equals negative 1/2 x plus 2. So that's how we can convert this notation into mx plus b. All right, so if we graph these, this one will touch at 4. And the slope is negative 3 over 2, meaning we rise down 3, 1, 2, 3. And we go across 2, 1, 2. Keep the pattern going, 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Go opposite, 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. So this creates that line for that first equation. That one. Next, we're going to do this one, which is start at 2 and go down 1 across 2, 1, 2, do down 1 across 2. So it's creating another line going this way. And the reason why I stopped is because we already found where they cross. So this point right here, 2, 1, this is the solution. Okay? All right. That was a lot of work, but good job on the review. I hope I see you tomorrow. Bye.